Welcome. In this video, we will explore how science moves beyond personal opinions and toward reliable discovery. We look at the value of related work, so why understanding what's already known is essential. We also unpack the idea of inquiry, asking questions that lead to insight. And finally, we will see how the scientific method helps us build knowledge that stands out on its own, independent of beliefs and biases. The basic aim of science is simple but powerful: to help us understand why things happen the way they do in the natural world. To do this, scientists don't start from scratch. They begin by exploring the current state of knowledge, what we call the related literature. This gives context, shows what's already been tried, and helps shape better questions. From there, they apply a research method, a structured way to explore, test, and build new understanding. So science isn't guesswork. It's a careful process built on what we already know, aimed at discovering what we don't. When doing research, there's always some related work, studies, findings, and ideas that came before. First, you need to formulate a problem. What topic are you exploring, and what specific issues does it involve? Next, you search the literature, looking for existing work that relates to our subject. This isn't just collecting papers. It's about reading carefully and using what you have learned to refine your problem. Here you may iterate several times. Then you evaluate the data, which sources truly add something valuable to the discussion. After that, you analyze and interpret the key findings. What conclusions have others reached? What patterns or contradictions do you see? And here's the important part. You find the gaps. What hasn't been answered yet? What is missing? That's where you come in with your own research question, filling this gap. A focused, meaningful question builds on what's known and contributes something new. At the heart of science is inquiry, to go from what we know to what we don't. Philosopher Charles Peirce described it like this: the purpose of reasoning is to discover something new based on what we already know. And reasoning is only useful if it actually leads us to truthful conclusions. But here's the twist. Peirce also pointed out that humans don't just seek truth. Often what we really want is psychological closure, a firm belief that feels satisfying even if it's not actually true. In other words, we are often more comfortable settling on an answer than continuing to question. That's why science matters. It pushes past the comfort of opinion and insists on methods that lead us closer to real understanding, even if the truth is complex or uncomfortable. So inquiry isn't just about answers. It's about learning to stay curious, question deeply, and resist the urge to stop too soon. To see how inquiry works in practice, let's look at a classic example from the history of science. Galileo Galilei, born in 1564 in Pisa, Italy. Galileo was a physicist, mathematician, and astronomer, often called the father of modern science. At the time, it was commonly believed that heavier objects fall faster than lighter ones, based on the assumption of Aristotle. But Galileo wasn't satisfied with that belief. He wanted to test it. So he dropped 2 iron balls of different heights from the top of the Leaning Tower of Pisa. And his hypothesis was bold for its time, that the force of gravity acts equally, regardless of the object's weight. And when the balls landed at the same time, Galileo has done something groundbreaking. He refuted an old belief and replaced it with evidence. His process followed the core steps of the scientific method. He started with an observation, he formed a hypothesis, and tested that hypothesis. And based on the results, either accepted or rejected it. Galileo's experiment is a powerful example of how inquiry, not opinion, moves science forward. Charles Peirce, the philosopher we mentioned earlier, outlined four main ways people try to settle beliefs. First, there's tenacity, simply holding on to your beliefs no matter what. This approach rejects facts that don't fit and can easily lead to denial of reality. Next is authority, where beliefs are dictated by power structures. This might seem stable, but it's dangerous when those in charge suppress truth or manipulate knowledge or for control. Then there is a priori method, settling belief based on what seems reasonable or has always felt right. This often leads us in circles, repeating opinions that were never tested in the first place. And finally, there's science. Science is different because it assumes that truth exists independently of anyone's opinion. It uses inquiry, testing, and revision to get closer to that truth over time. The scientific method follows a clear path. We form a hypothesis, we make logical deductions, carry out experiments, and then either verify observation or falsify and start again. This process is self-correcting. It doesn't rely on authority or belief, it relies on evidence. That's why in the long run, only science offers a reliable path to understanding, not because it's perfect, but because it's built to correct itself. Charles Peirce has proposed a model of scientific inquiry, which happens in three phases. First comes abduction. This is where we generate a theory. It's a creative leap, forming a possible explanation without knowing yet if it's true. Next is deduction. We take the theory and work out its practical consequences. What should happen if the theory is correct? And finally, we use induction. We test and evaluate the theory by observing the real world. Does it predict accurately? Can it help us explain and even control outcomes? This cycle, abduction, deduction, and induction, is how science moves from questions to knowledge, always open to revision, always grounded in evidence. It's not about proving you're right, it's about finding out what's real. In summary, inquiry always begins with curiosity, but true inquiry also demands discomfort and persistence. Galileo's method of observing, hypothesizing, testing, and concluding showed what real inquiry looks like. He wasn't following popular opinion, he was challenging it with evidence. Science is powerful because it builds on a process of self-correction. It doesn't rely on authority or gut feelings. It relies on what we can observe, test, and verify. In the end, truth isn't decided by belief, it's discovered through inquiry.